In our study in geometry and trigonometry, which is what we're leading into now, we need to know some basic facts about angles. So today in this lesson we're looking at positive and negative angles, coterminal angles, angle conversions, and the standard position of an angle. Now for conversions, we've got a couple of facts that we're going to rely on. One is that 180 degrees is equal to pi radians, and we're going to discuss what that means a little bit later. That's one of our basic facts. And another basic fact is that 1 degree is equal to 60 minutes, which is designated with this one quotation mark, and 1 minute, one quotation mark, equals 60 seconds, which has the double quotation marks. Another thing that we're going to have to watch as we're looking at our work in this particular unit is mode that the calculator set in. And the mode key you'll notice here is across that top row there, the middle key mode. So we're going to have to focus on that as well. So let's get into this some. So angles in standard position just means that one side of the angle is on the positive x-axis and the other side is located somewhere else. Okay, and if that other side, which is called the terminal side of the angle, is in the first quadrant, then we call that a quadrantal angle, even if it's in the second quadrant, third quadrant, or fourth quadrant. Okay, now notice here that this angle, because it's measured not counterclockwise, it's measured clockwise, it's going to be 120 degrees, negative 120 degrees. Anything that's measured counterclockwise, you start at the positive x-axis and go counterclockwise, that's a positive angle. So let's look at a little example here. Here we've got, so we're going to start with our angle on the positive x-axis, and we rotate counterclockwise to draw the terminal side of the angle. That's what this segment here is referring to, the terminal side. And so this angle that terminates in the first quadrant is a positive 63.5 degrees. This is the initial side, and the orange one we said was the terminal side of that angle. When we measure an angle like this with the initial side on the positive x-axis, we call that an angle in standard position. And so in the first quadrant, those angles measure anywhere from 0 to 90 degrees. If you have a standard position angle that terminates in the second quadrant, then this measures between 90 and 180. And if it terminates in the third quadrant, it's between 180 and 270. And notice now, this is rotating counterclockwise, so it's still positive. A standard position angle in quadrant 4 is between 270 and 360 degrees. So that angle that terminates here in the fourth quadrant is 318 degrees. Now, when we measure an angle, we can be very precise. And in this case, this angle measures 138.868204 degrees. And we call that decimal degrees. Now another way of measuring that is to change it to degrees, minutes, and seconds, using the fact that there's 60 minutes in 1 degree and 60 seconds in 1 minute. And then a third way to measure that same angle is in radian measure. So this one measures 2.423707 radians. Now, if the length of this part is 1, and it's not though, that's 5. But if this were 1 and we wrapped it around, that would be about 1, and that's going to be a little more than 2. So that's a radian, is the wrapping part, and we'll look at that a little more later. Okay, so we need to change decimal degrees to degrees, minutes, seconds by using these two facts. So if I have 138.868204 degrees, what I had a moment ago, and I want to change that to degrees, minutes, seconds, first of all, the degrees would be this whole number amount, what precedes that decimal point. And then we're going to take the decimal value and convert it to minutes by multiplying by this, the 60 minutes over 1 degree. So now we've got 52.0922040 minutes. So that's going to be equivalent to 52 minutes. And then we're going to take the decimal part of this and multiply it times this conversion fact of 60 seconds over 1 minute. And notice here the minutes cancel, so we end up with 5.53 seconds. So our answer to this problem, changing that degrees, decimal degrees to degrees, minutes, seconds, ends up being 138 degrees, 52 minutes, and a little more than 5 seconds, or almost 6 seconds. Now, that's to do it with conversion facts, but there is a way to do this in our calculator. So I want to show you that with the calculator. If I want to change this number to degrees, minutes, seconds, the first thing I have to do is make sure my mode of the calculator, now the mode is this key right here, is in decimal degree, it's in degree mode. So I would press the mode key, this key right here. I'd press that and see that degree is highlighted, not radian, but degree. Once I do that, then I would quit that screen and I'd go back and type in my decimal number. And these are the keys that I pressed to get to that point. And then I'd go second angle. Now, notice angle is above the apps key. So that's the reason I press second apps, and that gives me angles. And you have quite a few little choices that come up with that. We're going to choose DMS. That means convert to DMS. So we make that choice, hit enter, and it gives us our answer. 138 degrees, 52 minutes, 5.534 seconds. The same thing that we got by doing the arithmetic in the previous slide. So if I wanted to change this to decimal form, degrees, minutes to decimal form, I have to type it in with degrees and minutes. And here again, you would find that in your calculator, and that would be underneath this angle function right here. So we make sure our mode is set for degrees, and then we go to 17, type in the number 17, and then second apps, which is this angle, and enter. And then we're going to choose choice number 2, I think, is degrees. And then we're going to type in the number 24, and then go back to second angle, or apps, and then that's going to give us 4. Now, that's the way we do it in the calculator. If we were doing this by using the conversion facts, we get the same thing, 17.4 degrees. So you're welcome to do it either way, with the conversion facts or to use the built-in conversions in your calculator whenever you're making these changes back and forth. Now, to change decimal degrees to radians, we're going to use one of these two facts. I usually use this first one here, pi radians over 180 degrees. I'm trying to make my answer radians, so radians needs to be in the numerator. So if I took that same number to change it to radian measure, I multiply by pi radians over 180 degrees. The degrees cancel out, and we end up with this answer, 2.423707 radians. And so this is decimal degrees, the first one. The second one here is degrees, minutes, seconds. And this is that same angle in radian measure. Now, you can also change it to radian measure in your calculator. The one thing that's different here is the mode of your calculator needs to be in radians. So you go back and you can type in the number, 138.868204, put the degree symbol on it by doing that second apps, which is angle. And if the mode is set for radians, that's what you got to check. Now, if the mode is set for degrees, this is what's going to show up, a decimal degree answer. If the mode is set for radians, then you get your radian answer. Okay, so you just have to be careful with that. The mode needs to be set for what you want your answer to be in. Okay. So if I want to express 1.36 radians in degrees, then I can use this fact, 180 degrees over pi, because this is radian and 1.36 is radians, and they cancel out. So that gives me my answer. Or I can type it in my calculator, 1.36, and under that same function, second apps, where's angle, you have a choice for that R. That stands for radian. Type that in, but make sure the mode of your calculator is set for degrees, and it'll produce a degree answer for you. Okay? And then if you want to change degrees to radians, just make sure your mode's set for radians. Okay? And when you hit key and enter, it should give you a radian measurement. So whatever you're changing to is what you want the mode of the calculator to be in. Now, a coterminal angle, this is one of the little definitions, is just an angle that ends at the same terminal side as the original angle. So like this particular angle here, this side that's in blue, on the x-axis, that's the initial side, and the terminal side is this one. That gives me the 139. So a coterminal angle could start here and go all the way around and then come back. So what we were doing is taking that 139 and adding on 360 degrees. Or I could go in the opposite direction. I could start here on the initial side and go to the left, go clockwise, and that gives me a negative angle measure, taking 360 away from 139. And we'll stop right there.